So today we're going to be dealing with linear equations in two variables. So you might be asking yourself, well, what does that mean? What is a linear equation in two variables? Well, it's the simplest model for relating two variables, and it's usually done in the form y equals mx plus b. And we're going to get into what each of these different components mean. But first, we need to understand some terms that are going to be thrown around a lot during this episode. So a term that you're going to hear a lot is the slope. And you can even see here, we have slope-intercept form and we have point-slope form. So obviously slope is an important concept that you're going to want to hold on to for this episode as well as in the future, because slope is just something that's used a lot in graphing and in math in general. So what the slope is the rise over the run. And it refers to this m value here. The m value will be is your slope. And so the rise and run, even those two things sound a little bit ambiguous. The rise is just the y value, and the run is the x value. So let's say you have a slope of 1, for example. If your m is 1, that means for every one increase, for every one incrementation on the x value, you also have a one incrementation on the rise value. So that would be like just a y equals, I don't know, y equals x plus 3 type of slope. It would start up, the y-intercept would be at 3, and for each addition onto the x value, you get an equal addition on the y value. And I don't know if that makes sense now, but we will be exploring this later, so just keep that in mind. Next, we're going to be talking about the slope-intercept form, which you see here, and this equation is actually slope-intercept form. So y equals mx plus b is the slope-intercept form of the equation of a line. And like I said, your m is your slope. So it's the rise over the run, the y over the x. So your m is your slope, and your y-intercept is going to be at 0, b. So in that last example I gave where I said y equals x plus 3, you see that b in this case would be 3. And so that's how I know my y-intercept is at 0, 3. Our next form we're going to be dealing with is the point-slope form of the equation of the line. So that is y minus y1 equals m times x minus x1. That's the point-slope form of the equation. So usually in this type of thing, we would be given the slope, and we'd be given an x and a y value, and so we would plug that slope in for here, and then we would plug the x1 and y1 values in here, and it would ask us something like write it in slope-intercept form or something like that. I just want to go back to the slope really quickly. To find the slope of a line that's passing through 2 points, there's actually a formula for that which you're going to want to memorize. It's m equals y2 minus y1 over x2 minus x1. And the only condition here is that x2 cannot be the same as x1. They can't be the same values, because if you subtract them, you'd get a number over 0, which is undefined. So this is going to be used to find the m value. Now we're going to talk about parallel and perpendicular lines. So if you're given two slope-intercept form equations, or even if you're given two lines, you can tell that they're parallel if two distinct non-vertical lines are parallel, if and only if their slopes are equal. So let's say we have y equals 2x plus 7, and then let's say we have y equals 1/2 x plus 7, and then let's say we have y equals 2x plus 3. And you're asked which one of these equations are parallel. Well, we know that in order to be parallel, they can only be parallel if and only if their slopes are the same. And we know that the slope is this value in front of the x. So we look here and we say, oh, is 2 is the same as 1/2? Obviously not. So these can't be parallel. Is 2 here equal to 2 there? Yes. These two equations, the first and the third one, are parallel even though the y-intercepts are different. So that's how you know. Then we get to perpendicular lines. And two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. So let's go back to that y equals 2x plus 7 example. So first, let's try to get this into a perpendicular form. So we know they have to be negative and they have to be reciprocal. Well, the negative version of 2 is negative 2. So we're going to have negative 2x plus 7. And the reciprocal is this, the numerator and the denominator sort of flipped. So if you want to think about it this way, in this existing form as it is right now, this is negative 2 over 1. If we make that the reciprocal, we have to switch the numerator and the denominator, meaning we'd have negative 1/2 x plus 7. These two equations, this one and this one, they are perpendicular. So that's how you would know if they're perpendicular. And then if we were going to list the other equations of lines, these are equations of like lines. Like I'm not talking a parabola here or a quadratic function. Like I'm talking a strictly linear line. So we have the general form, which is ax plus by plus c equals 0. And again, actually you may not need to memorize these, but it's good to have a knowledge of them. So if we want to do a vertical line, that's going to be x equals a, and a is any value, any real number. If we want a horizontal line, that's going to be y equals b. So we're going to have b being any real number. Vertical line, of course, looking like that. Horizontal, looking like that. A slope-intercept form, like we already said, y equals mx plus b. I'm not going to bother writing that out. You can just go back in the video. Point slope form, once again, we already wrote that out. Now there's two-point form, which is almost identical to point slope form. It's just that instead of writing m, you write the equation to find m, which is the y2 minus y1 over x2 minus x1. So that would end up looking like y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. And that would be your two-point form. So in this next question, we are asked to identify the line that has each slope, and we're given this graph with three lines labeled L1, L2, and L3, and we're given three slopes here. We're given that one of the slopes is 2/3, One of them is undefined, and the other one is -2. Now, this whole problem can be solved just through the process of elimination, and here's how. If a slope is undefined, it means it's either going straight up or straight sideways, because that's when there is no slope, there is no rise over run. Or I suppose, no, if it's undefined, it just means it's going straight up and down, I believe, because it means there's no run, there's no x value, the x value is 0, so as a fraction it would be undefined. If it was horizontal, the slope would be 0. So if we're looking for where m is undefined, I'm going to be looking for lines that are going straight up and down, and I see that that is L3. So I can confidently say that m is undefined corresponds with L3. Next, I want to take a look at the nature of these remaining two lines. I see that L1 is sloping downward. It has a negative facing slope, meaning that the number is going to be negative. And in L2, it's a positive slope, meaning the number is going to be positive. Well, out of our remaining two options, only one of these is negative and one of these is positive. So I can say that this is L1 and this is L2. I can also say that this is L1 because the larger the slope is, or I guess the larger the value of the slope is, the steeper it's going to be. So a negative 1 slope might look something like this, but a -2 slope is going to look something like that. And then a -3 slope is going to look something like that, and so on and so forth. It just gets steeper and steeper. Whereas as you start to get closer and closer to 0, as the slope gets closer and closer to 0, the slope becomes more gradual. So maybe a one slope, a positive 1 slope might look like that. I'll make that a little bit steeper actually. Positive 1 slope looks like that, and then maybe a 1/2 slope looks like that, and then maybe a 1/3 slope looks like that, and so on and so forth. So those are some other indicators you could use to solve this problem. Okay, so in this next question we are asked to sketch the line through the point with the indicated slopes on the same set of coordinate axes. And the point we're given is 2, 3, and we're asked to graph 4 different lines with 4 different slopes, and the slopes are a slope of 0, a slope of 1, a slope of 2, and a slope of -3. So first we're going to graph the point 2, 3. We're going to go 2 to the right of the origin and 3 above the origin, or 3 above the x-axis, I suppose. For the slope 0, if you remember from the last problem, there's a very distinct difference between a slope of 0 and an undefined slope. A slope of 0 looks like this, because you're basically saying your rise is 0 over some number x. X is a variable in this case, it can be any real number. 0 over a number is equal to 0. So that's why you'd get this horizontal line. If you have a vertical line like this, then you have some rise value, some y value, and y is a variable, it can be any real number, over 0. There's no increase in the x here, it's only increasing on the y. And a fraction where the denominator is 0 is undefined. So those are the two distinct differences that you're going to want to know. So for a slope of 0, there's going to be absolutely no rise in this line. It's just going to be a horizontal line, like this. So then for a slope of 1, that means the ratio between the y and the x is a positive 1, meaning that for every value, for every time we go to the right on the x-axis by 1, we're also going to go up on the y-axis by 1 to maintain that 1-to-1 ratio. So we're going to go over 1, up 1, over 1, up 1, just like that. And even on the negative side, we're going to go down 1 to the left 1, and we're still maintaining that 1-to-1 ratio. We're going to go down 1 to the right 1, down 1 to the right 1, and so on and so forth. And you can fill in the rest of these you can fill in the rest of these dots on your own, but for the sake of time, I'm just going to stop right there and sketch this graph like this. Now we have a slope of 2, which means for every one value, like if we move 1 to the right on the x value, we're going to go 2 up on the y value, because remember, it's the rise over the run. So to maintain a slope of 2, we're going to have 2 increases in the y value for every 1 increase in the x value, if that makes any sense. So for this one, we're going to go to the right 1, up 2. And even down here, we're going to go to the left 1 and down 2. So we're going to go to the left 1 and then down 2. To the left 1, down 2. So then we will fill in the line, and it will look something like this. Forgive me if my line isn't 100% straight. And you can see here what I was talking about earlier. The greater the slope value is, the steeper the line is going to be. We can see this slope of 1 is less steep than this slope of 2. So that's just what I was saying earlier. Now we have a slope of -3. So this means for every 1 to the right we go on the x, we're going to go down 3 on the y. And for every 1 to the left we go on x, we're going to go up 3 on the y. So we're going to go down 3 and to the right 1. Then we're going to go down another 3 and then to the right another 1. And then up here we're going to go to the left 1 and then up another 3, which is actually going to be off the graph. And I'm trying to draw a straight line here, so like that, and then we draw the other half of the line like this. And you can see this one is a slope of -3. It's even steeper than the slope of 2 because 3 is greater than 2. So that's how you do that problem. Okay, so in this next question we're given the exact same instructions to sketch the lines through the point with the indicated slopes on the same set of coordinate axes, but this time we're given a different point, which is -4, 1, and different slopes that they want us to graph through the point. Those slopes are 3, -3, 1/2, and undefined. So now that you saw how to do the last one, I want you to pause the video here, try this on your own, and we'll come back and see how you did. So assuming you've paused the video and done this on your own, let's see how this problem should have been solved, and if you got it correct. So first of all, we're going to start by graphing the point -4, 1. We're going to the left of the origin 4, and then up 1. Now the first slope it wants us to graph is 3. So remember that the slope is the ratio of the y value over the x, the rise over the run. So in order to have a ratio of 3, that's equivalent to 3 over 1. Meaning for every space we move in the x-axis, we move 3 in the y-axis. So if we move to the right by 1, that's on the x-axis. So then we go up 3. We're going to just repeat that same process of going right 1 and up 3, and this next point is going to be a little bit off the graph, but that's okay. And then even if we go left, we go to the left 1 and down 3. So that's going to be 1, 2, 3 down here. And then we can do a very rough sketch of our graph right here and just assume that's a straight line, or imagine that being a straight line. Then we have negative 4, 1, but a slope of negative 3. So this is going to be very similar to the first slope. It's just going to be negative, meaning it's going to be going downwards as you move to the right. So in order to do that, it would be something like we go to the right one and then down 3. So we go to the right one here, and then we go down 3 to here. And then we go to the right one, and then we go down another 3. So we go 1, 2, 3 down here. Similarly, we go to the left one, and then we would go up 3. 1, 2, 3 right here. And then we can just sketch that line right there. And that would be how you do negative 3. Then for 1/2, well, let's get rid of this for a second. For 1/2, now we're looking at a ratio like this. Meaning for every amount we move on the y, we're going to move 2 of that on the x. So if we're at the point negative 4, 1, I would go over 2 to here and then up 1. And I would just keep repeating that. Over 2, because that's the x value, or that's the run, if you will, and then up 1, because that's the rise. I'm just going to keep doing that, up 2 over 1. And I'm going to stop at this just third point right here, at least I'm going to stop at this third point here, but your teacher may want you to go until you're off the graph, or maybe he or she wants you to graph 3 or 4 or 5 points. So I just ask the teacher in that case. So now all I have to do is sketch the graph, and once again you see how it is more gradual than these 3 or negative 3. The closer you get to 0, the closer you're going to get to a horizontal line. Now we're getting to undefined. If you recall from what I said earlier, in order to get undefined, you have to have a fraction over 0, meaning there is absolutely no run. There's no movement on the x-axis. It's only movement on the y-axis. So it's just going to be a vertical line, basically. So to graph an undefined line, you would just graph this. And that would be your undefined. Okay, so in this next question we are asked to find the slope and y-intercept, if possible, of the equation of the line. And then we are asked to also sketch the line. And the equation we're given is y equals 5x plus 3. So to find the slope, remember, this is in slope-intercept form. It's in y equals mx plus b form. And m is our slope. This is actually going to be our slope right here. So we look to the coefficient of x, which we see as 5, and we say that our slope is equal to 5. Now, if you remember, our y-intercept is going to be 0, b. And if you look here, this b on this equation is 3. So our y-intercept is 0, 3. Now all that's left to do is graph it. So we're going to graph this at 0, 3, so we're going to put a point right there, so that's our first point. And we know that it has a slope of 5, meaning it's going to go upwards as we move from left to right. If I move any further to the right, though, it's going to go off the graph, so for now I'm going to go to the left. So if we go to the left one, that means we're going to go down 5, because we're trying to maintain that ratio of 5 to 1. So we go 1 on the x, and then we go 1, 2, 3, 4, 5 down on the y. And these are the only 2 points that I'm able to graph that are on the graph. But if we wanted to sketch it, we know it would look pretty steep, something like this. Probably even steeper than that, actually. Something like this. So yeah, just a very rough sketch of the equation, but obviously it would be pretty steep. So in this next question, we're asked the exact same thing, just a different equation. And our equation this time is y equals negative 1/2 x plus 4. So once again, we're going to, you don't have to write this step out, but I'm doing it for simplicity's sake. So now we have kind of a mirrored form of the equation where we can see it in slope-intercept form, but everything is written in terms of variables. And like I said, our slope is going to be this m value, the coefficient of x. So our slope is going to be negative 1/2, and our y-intercept, you remember, is 0, b. So in this instance, it's going to be 0, 4. Then when we go to graph it, we're going to graph a point at 0, 4. And since the slope is negative 1/2, it's going to be downward facing, and for every one movement we make on the, if we go to the right 1 on the x-axis, we're going to go down 2, and if we go left 1, we're going to go up 2. So we're going to go right 1 and then down 2. No, I messed that up. It's negative 1/2, so our ratio is going to look like this, meaning for every 2, 2 on the right is 1 down, and 2 on the left is 1 up. So we're going to go 2 right, and then 1 down, 2 right, 1 down, and then here we're going to go 2 left, 1 up. And we can see it is much more gradual, much less steep than the slope of 5. And that's how you do that. Okay, so in this next question we are asked the exact same thing, to find the slope and the y-intercept, if possible, of the equation of the line and to sketch the line. And the equation we're given is 5x minus 2 equals 0. And I want you to notice that there's a distinct difference between this and the other equations we've seen in previous problems. In previous problems we've seen equations written in some sort of y equals mx plus b format. However, in this one there is no y, so we're just going to solve for x and see what we get. So we're going to add 2 to both sides, and we get 5x is equal to 2, and then we divide by 5 on both sides, and we get x is equal to 2/5. Now let's try to find the slope. The reason I say it with apprehension is because you can't really find the slope in this problem. The slope is undefined. You just have an x value, meaning that for any y value you plug in, be it 0, 1, -1, 1 million, your x value is always going to be x equals 2/5. So because of that, there's no slope, because it's going to look vertical, or the slope is going to be undefined. So we're going to write m equals UND for undefined. And in terms of the y-intercept, there is no y-intercept because every point will be where x is equal to 2/5. So if you look at a graph, let's say 2/5 is just over here. So we have this vertical line here. There is no point on this graph where the graph of the equation crosses the y-axis, meaning there is no y-intercept. So let's try to graph this then. So 2/5 is going to be somewhere in here, somewhere between 0 and 1. I'm going to put it right over here, and we're just going to sketch a line, a vertical line. And you see there is no point where this line crosses the y-axis. And for every y value, it's vertical because for every y value you plug in, you get the x value of 2/5. So at y equals 0, x is 2/5. At y equals 1, x is 2/5. At y equals -1, x is 2/5, so on and so forth. So hopefully that makes a little bit more sense. Okay, so in this next problem, we are asked the exact same thing, just a different equation. The equation now is 7x plus 6y equals 30. So now that you've seen how to do the last few, I want you to pause this one, try it on your own, unpause it, and we'll see how you did. So assuming you've tried this on your own, let's see how this problem should be done and see if you got it correct. So we're given the equation 7x plus 6y equals 30, and we're asked to find the slope and the y-intercept if possible, and then to sketch the graph. Well, what I would do is I would manipulate this equation to get it in terms of y on one side and mx plus b on the other side. So in order to do that, I'm going to subtract 7x on both sides. So that's going to give me 6y equals negative 7x plus 30. Then I'm going to divide by 6 on both sides. That 6 could be written better. So then we're left with y equals negative 7/6 x plus 5. Now this looks like a more familiar form for us. This looks like the mx plus b form, the slope-intercept form. And from here I know that my slope, my m value, will be the coefficient of x, so it's going to be negative 7/6, and my y-intercept will be 0, this b value. So my y-intercept is going to be 0, 5. And then we can go to sketch the graph. So my y-intercept is going to be all the way up here. And you see our ratio of rise over run is negative 7/6, meaning that for every 6 units we go to the right on the x-axis, we go down 7 units on the y-axis. And conversely, for every 6 units we go left on the x-axis, we go up 7 units. So we're going to go right 6 units, so that's going to be just off the graph here, and then down 7 units. So this will be 5, and then 6, 7. So it's going to look something like that, and then I'm going to do a very rough sketch and just imagine it as a straight line. So in this next question, we are given the exact same question, just a different equation. So now that you've seen how to do the last few, I want you to try this on your own. Pause it, pause the video, and then come back to this when you're done and see how you did. So assuming you've paused the video and tried this on your own, let's see how you did. The equation we're given is y minus 3 equals 0. Again, we could make this equation closer to the y equals mx plus b form that we're more familiar with just by adding 3 to both sides. So that's what I'm going to do. And I have y equals 3. Now notice here it doesn't say 3x plus something, it doesn't even say just 3x, it is just 3. So that means we don't have a m value, but it's not we don't have an m value in the sense that it's undefined. It's we don't have an m value in the sense that our m is 0. So I suppose we do have an m value, it's just 0, because if you think about it, for every x value we have on this equation, our y will always be 3. So on a graph it will look something like this. And we know horizontal lines have a slope of 0, because let's say at x equals 1, y is 3, at x equals 2, y is 3, at x equals negative 4 quadrillion, y equals 3. So knowing that, actually let me redraw this graph here. So knowing that the graph will always be this unchanging horizontal line at y equals 3, we can say that our y-intercept is just going to be 0, 3. Like this. So then when we go to graph it, we're going to graph our y-intercept at 0, 3. And because our equation is just y equals 3, like I said before, at x equals 1, y will be 3. At x equals 2, y will be 3. At every single point along this axis, along the x-axis, both on the positive and negative sides, y will be equal to 3. So we just draw a horizontal line like this, and that's how you would do that one. Okay, so in this next question, it's the exact same question, just a different equation. X plus 5 equals 0. And we've already seen something similar to this, or at least our answer is going to be the same as a problem we've done previously. So what I would start by doing is subtracting 5 on both sides. So we have x equals negative 5. So if we look here, this means that at any given y value you want to plug in, x will always be equal to negative 5. So at y equals 0, x will be negative 5. And let's say negative 5 is over here. At y equals 1, y equals 2, y equals 3, y equals negative 1, negative 2, negative 3. X will always be this negative 5 value here. So when you see a vertical line like this, you should always be thinking slope is undefined. And you also can see that on a vertical line like this, it will never cross the y-axis, meaning there is no y-intercept. There's no need to write y-intercept because there isn't any. So when we go to graph this, we're going to graph our point at negative 5 and just draw a vertical line straight up and down.